Hello all, welcome to Pamita AI World. My name is Pamita Singh Kandari. I'm teaching you the covariance part. What is covariance? Covariance is nothing but it tells us the direction. It tells us the direction, or we can say relationship between two variables. Two variables, whether they are positive, negative or 0. Fine. Covariance tells us that. So why I'm teaching you covariance? Because in my all the previous videos I taught you the matrix and their determinants. Fine. So matrix and their determinants, I taught you this part. Why I have given you the all the roughly examples of matrix and determinants? Because I wanted to teach you the principal component analysis. And why I was teaching you the principal component analysis? Because I wanted to teach you the how we will reduce the problem of overfitting, and how we'll calculate the covariance matrix. Fine. So under principal component analysis many terms comes, and it is a very vast topic. The mathematical expression of PCA would be very vast topic. So this vast topic of mathematical expression part of this particular PCA, I'll give you the mathematical expression in the next video. In this particular video I'll give you the roughly example of covariance and correlation, so that I can teach you the covariance matrix clearly. Fine. So in this particular video I'll give you this example. So what I'm going to teach you first, what is covariance, although I have given you one big video of covariance previously. So covariance is what? Covariance is nothing but covariance tells us the relationship between two variables. Fine. It tells us relationship between two variables, whether they are positive, negative or 0. Fine. So positive correlation is means height and weight. Height is 50 kg, 60 kg, 70 kg, 80 kg. Fine. And sorry, this is weight, and height is 160 kg, 160 centimeter, 162 centimeter, 164 centimeter. Fine. Height is like this. So positive, I am giving you the example of positive. If a person having 50 kg weight, his height is 60 kg. So I am denoting this data point here. Fine. If a person of 80 kg, his height is 164 kg. I am denoting this data point here. If a person is of 70 kg, his height is 162 kg. So I am denoting this data point here. So what we are seeing here is directly we are watching that the graph is going straight upward. Fine. How upward? If weight is increasing, fine, height is also increasing. So this way we can say that the covariance is in positive direction. Fine. Positive direction. Same way if we see the negative directions, let's suppose if this is weight of a person and workout of a person. If a person of 50 kg person, fine, he wants to 58 kg person, he is working less, he is burning calorie less burning. 67 kg he is doing workout more, like this. So if this graph is going downward, so like data points are like this, but graph is going downward. Fine. How? More weight kg person is doing less workout. Fine. If a person is very fatty, he is not doing workout, he is lying on the bed, or he is just working in their working hours, but they are working less workout in the gym, or they are doing less exercise. So what does that showing? This showing a negative direction or negative relationship between two variables. Fine. Weight is more, workout is less. So this type of relationship showing us that it is going on the negative direction. Same way, if the weight and height is 0, so weight and height, we can say if the data is not changing, whether it is weight is 50 kg or 60 kg, height is somewhere and workout is somewhere, but the data points is showing this way, so it is showing 0, nothing is changing here. Same way, nothing is changing here. So there is no covariance, there is no relationship, not any kind of single relationship is mentioning there. So this is called covariance. Fine. So let's suppose I am giving you one example here, directly I am giving you so that you can understand. And what is correlation? Because in that PCA we will see the correlation also, mathematical expression, when we see the mathematical part. Correlation is nothing but it shows that how much strong a relationship is between two variables. How much strong a relationship is between two variables, this is shown by the correlation part. How much strong a relationship is, strong or weak, we can say weak, strong or weak, strong or weak. ठीक है. So correlation shows that. So height weight kg. So height weight is, if height is 181 kg, 164 kg, height is this is centimeter. Fine. Let's suppose height is 175 centimeter, 187 centimeter, 173 centimeter, 191 centimeter, 158 centimeter, 169 centimeter, 171 centimeter, 178 centimeter. Fine. And weight is 80 kg, 53 kg, 77 kg, 94 kg, 63, 84, 45, 74, 70, 84. So covariance is 143. And same way height is, weight is 181, 164, 175, 187, 173, 191, 158, 169, 171 and 178. And weight is 80,000, 53,000, 77,000, 94,000, 63,000, 88,000, 45,000, 74,000, 70,000 and 84,000. 143,155 covariance is this. So if covariance now don't worry about how I calculated covariance 143. This thing I'll teach you in my next upcoming video. Just focus on what I'm just wanted to clear your concept here. Saying that this covariance is 143 here. Same way, if we'll convert that 80 kg weight into 1000 kg grams in grams, so it is 80,000 gram. Fine. So this would be 1 lakh covariances would be 1,43,155. Fine. Here, just because we changed the unit of weight, the covariance also changed. But what happens in correlation concepts, it tells us that how strong a relationship, but covariance tells us the how direction of relationship is changing. Fine. Direction of relationship is changing, how it is changing here. So how it is changing? It is changing like here covariance is 143, but same way here covariance is increasing in the in a big way. But in correlation, it tells us the correlation. For example, if we want to calculate the correlation of this particular table here, so correlation of this particular table which is mentioning in the correlationship, which is mentioned here, it's would be 0.9, it would be 0.922, and the correlation of this thing would be 0.922 here. So correlation is same here, but it is nearby to the 1, it is also nearby to the 1. So what does that correlation is showing us? It is showing the strong relationship between height and weight. 0.922 is showing strong relation between height and weight because it is near to 1. What happens if it was showing us in negative way? Like if suppose it came like -74, it means that the weight and height correlationship is going another direction, or it is a weak relationship between these two particular height and weight variables. So correlation and covariance is nothing but correlation tells us that how strong and how weak is the relationship between two variables, and covariance tells us that how two variables direction is going, whether they are going in positive or negative, or they are not showing anything and they are 0. So this is the main crux of this video. Now congratulations to all the English medium students, because now we will jump to the main part of all the history we have studied here related to linear algebra. In my next video I will teach you the PCA, principal component analysis, and this PCA is very vast topic. Please concentrate when I will teach you, because on this particular topic only, and under this particular topic only, I will cover 10 to 15 main topics under this PCA, which are very important to build the AI model, and it would be very fun to teach you, because these are very for me it is very easy to understand. Of course it would be easy to all of you to understand this particular topic. Thanks a lot for trusting Pamita AI World. Keep learning, happy learning. If you like the video, please like and subscribe my YouTube channel.